Alright, it is time to talk about Newton's second law of motion. This is going to be 8.6c as well. This is the second video in the laws. This one's pretty easy, so let's just get going. Make sure that you have your 4-page boxes of notes that look like this. Let's get going. Alright, we want to talk about how Newton's law is related to net force, what's the relationship between net force and mass, and what's the relationship between net force and acceleration. Remember, we've already talked about a lot of these words. Acceleration is any change in motion, so we're really going to be focusing on the acceleration of an object. Alright, let's go ahead and take care of that first box on your notes. We have F equals M times A. That is the formula. And if you recall on our brain dumps, we've already been doing our triangle. And so I always have you circle force. And so what we circle goes on top. F equals M times A. Okay, so if I was looking for acceleration, I would, of course, divide the force and the mass. And this is really important to pay attention to. These are units that you will commonly see these variables in. So force is always in newtons. Mass could be kilograms, could be grams, but remember, acceleration is always meters per second squared. Alright, our next box says F stands for, you know it, force. If you see force or net force, all means the same thing. And just to review, remember, a force is a push or pull. We practiced that when we did the arrows that were acting on objects like the boxes. Force, push or pull. These are pushing forces, and then, of course, this one's going to be a pulling force. If F stands for force, then what type of forces are we dealing with? Remember, you have balanced versus unbalanced. So I bet you already figured out we are dealing with unbalanced forces. Because a balanced force is not going to cause an object to have a change in motion. So remember, balance will not change the object's motion, but unbalanced can change the object's motion. Alrighty, so the rest of our formula, M stands for mass. Okay, remember, mass can be in things like kilograms or grams, either one. A, is always going to be acceleration. And then below our unit, we've already told you this, meters per second squared is always an acceleration. If you see meters per second, that's a speed. Meters per second squared is automatically an acceleration. So if you see something that says 4 meters per second squared in an equation, that's an acceleration. You're not doing a speed formula. Then acceleration is going to be produced when an unbalanced force acts on an object, because remember, we're dealing with unbalanced forces that are changing the motion of the object. So an example's down here. I've got a mass of 20 kilograms, because I see kilograms, that tells me it's a mass, and then I see meters per second squared, that is an acceleration. So there's the formula, F equals M times A. I take the 20 grams times the 3 meters per second squared. I'm going to end up with 60 newtons, because force is always measured in newtons. That's why I keep telling y'all in class, when you are calculating net force, even with the forces acting on the boxes, you guys give me a number, and I say what? 0 what? 2 what? 2 newtons. Make sure you always have force in newtons. Alrighty. The last box, acceleration is a change in the motion of an object. Acceleration is caused by unbalanced forces, because remember, our unbalanced forces are the ones that cause a change in motion. So the greater the force applied to an object, the greater the object's acceleration. The greater the mass of the object, the slower the object's acceleration will be. So let's look at an example. Alright, so let's look at this example. So I have 2 vehicles here. I have the first one that has a mass of 40 kilograms. So I have a mass of 40 kilograms. And then I have a force of 60 newtons. So I've got to manipulate that formula to figure out what the acceleration will be in meters per second squared. Okay, I've got another vehicle that has a mass of 190 kilograms, and it has a force of also 60 newtons. And I've got to do some math to figure out what my acceleration will be in meters per second squared. So if I remember in my triangle, F is m times a. I'm looking for my a, so I've got to take my force and divide it by my acceleration. So I know logically, though, even though both vehicles have the same amount of force being applied, they've got different masses, and those different masses are going to be what make the difference. So which one do you guys think should have the greater acceleration? Well, if you said the smaller car, you're exactly right. It should. So I'm going to do the math, and this is what I came up with. I ended up with my car having an acceleration of 1.5 meters per second squared, and then my truck only has 0.31 meters per second squared. So, acceleration is caused by unbalanced forces. The greater the mass, the less acceleration you'll have. The smaller the mass, the more acceleration you have. And that's pretty much the gist of what you need to know for Newton's second law, and we will practice formulas.